We've represented energy and the conservation of energy using pie charts. Each pie chart represents 100% of the energy that is conserved as it transforms from one form to the other. Since we're dealing with one whole amount of energy and individual parts of that whole, percentages become very helpful when we're trying to understand how energy transforms from one form to the others. If you need to calculate how much energy is present in a certain percentage of the total energy, all you need to do is divide the percentage by 100. This is simply as easy as moving the decimal 2 places to the left. Then you're going to multiply the total amount of energy by this quotient. Percentages are great for communicating values, communicating amounts. Decimals, or the decimal version of a percentage, which we get by dividing by 100, this value is great for calculating. Let's apply this to an example. A basketball hits the ground with 85 joules of energy, and 62% of the energy is transformed into elastic energy. How much energy is transformed into elastic energy? There's a difference between the percentage of energy and the amount of energy. We started with 85 joules. I need to find what 62% of 85 is. This will tell me how much energy was transformed into elastic energy. I start by dividing the percentage by 100. 62% divided by 100 gives me 0.62. This is again just as easy as moving that decimal 2 places to the left. Next, I'm going to multiply the total amount of energy by this new quotient. So I'm going to take the total amount, 85 joules, times 0.62 to get 52.7 joules. That's how much elastic energy is present when the ball compresses, when it hits the ground. This means that the other 38% of the energy had to go somewhere. We've observed this before by looking at energy pie charts. At the beginning, or at the top of the bounce, assuming the ball's just dropped straight down, we start with just gravitational energy. The ball's not moving, it's only off the ground, so it's all gravitational. When it hits the ground, it bounces, or it compresses the ball so it can bounce back up. Most of this energy, or 62% in this case, turned into elastic. The rest was E-dis. This is why the ball only bounces up about 62% of the height on the first bounce. Instead of knowing what percent of the energy is transformed into something useful like elastic energy, sometimes you'll be told what percentage of the energy is transformed into dissipated energy. We can use this information to find how much energy we still have that's useful, that hasn't been dissipated. To complete a problem like this, start by subtracting the percentage that is lost from 100%. Because it's lost, we're subtracting it from the total amount of energy, or 100% of the energy. Divide this difference by 100. It's a percentage right now. We need to turn it into a decimal. Percentages are great for communicating values. Decimals are great for calculating values. Then we're going to multiply the original amount of energy by this new product. By subtracting from 100, we're representing the percentage of energy that is not dissipated. In this example, we have a car that begins to slow down, but does not stop. It had 56,250 joules of kinetic motion energy before slowing down and dissipating 25% of its energy while braking. How much energy is still kinetic? In this case, we know what percentage of the energy is dissipated, so we should be able to find what percent of the energy is still being used to move the car. Subtract the percentage that is lost from 100%. So we have 100% of the energy, we dissipated 25%. So we're not losing that energy, we're just transforming it into something else. This means that after dissipating 25%, 75% of that energy is still helping the car move forward. There's less than 100%, which is why the car moves slowly. Now we're going to divide this difference by 100. I want to turn that percentage into a decimal form, so 0.75, and then multiply the original amount by the product. We started with 56,250 joules of energy. That's 100% of our energy. I need to know what is 75% of the energy. That means that 42,187.5 joules of this energy is still being used to move the car forward. The amount of kinetic motion energy decreased, which explains why the velocity of the car decreased. The car started with 100% kinetic energy, and as it moved, it dissipated 25%. Using this energy moving forward, we would be able to take our kinetic motion energy and solve for the velocity of the car. If you needed to find a percentage of energy, to find what part it is of the whole amount of energy, you would simply divide the final amount of energy by the original amount of energy. We're going to take the part and divide it by the whole. Multiply this quotient by 100. That'll turn it into a percentage. A ball is falling. It begins with 250 joules of gravitational energy. Later in its fall, it has only 100 joules of gravitational energy. What percentage of the original energy is gravitational at this point? It started with all gravitational. 100% of the energy was gravitational. That 100% represents 250 joules. Later, there's only 100 joules, so I can compare how much gravitational energy I have later to how much I started with in my total amount of energy. Start by dividing the final amount of energy, or in this case the specific amount of gravitational energy, compared to the original amount of energy. So I would take 100 divided by 250 to get 0.4. Multiply this quotient by 100, that's going to turn it into a percentage. 0.4 times 100 gives me 40%. This means that at this point in the object's motion, or the ball's motion, 40% of the energy is still gravitational. As the ball falls, it starts with all gravitational and speeds up as it moves towards the ground. We've observed this before. Objects moving towards the Earth accelerate at a rate of 9.8 meters per second squared. That means we started with all gravitational energy, and as time moved forward, we had less and less because the height decreased. We only have, at that point in the object's motion, 40% gravitational. The rest, the other 60%, has to be kinetic. If we took the original 250 joules and multiplied by 0.6, or 60% as a decimal, like we did in our first example, we could find how much kinetic energy is present.